Hello, everybody, and welcome to today's webinar. My name is Scott, and this is,
Mary.
and we are just about ready to share our screen. So give me 1 second here, and we will share the correct screen with you and be ready to go. So today's webinar is going to be talking about luxury vinyl elevated, flooring trends and radiant heating compatibility with LVT and LVP. So let me just get the our tabletop set up here correctly so we know that we're on the air. And let's go ahead and move on to I've got all kinds of warnings going on here. There we go. Let's try to do this. Nope, that didn't work. We're going to try this again. Now you can ask a question if you like. After all of our moving around, our shell game here is done. And you can ask us a question, just type it in there and we will be glad to answer that as we go. We also had one person put in a question in advance, and we always enjoy that. So we'll be getting to your question, Dondi, when we get to that point. So we have got your question. We are going to answer it. So Mary, tell us about what we're going to be talking about in today's webinar.
So the overview for today's webinar is going to be trends in LVT and LVP flooring. As we know, that's very popular. Compatibility with radiant heating, installation essentials and best practices, and recommended systems and thermostats, as well as the tools for planning and how to quote.
This is a very, very popular subject. So let's go ahead and talk about what is so great about radiant heating. Radiant heating has been around for a long time, but it's mostly been done in the old days with hot water, which was quite a job. And we're going to be talking about the differences between hot water and electric. But tell us now, what's the difference between forced air heating and radiant heating?
So with forced air heating, often the air is going to be coming in through your floor vent register. It's going to circulate upwards and then go back down through the next registers. Forced air heating systems often result in very uneven heating, and they can detract from your home comfort and efficiency of how you actually enjoy your room. With electric radiant heating is going to warm your body and all of the objects in the room, not just the air. The heat's going to stay concentrated at the floor level or at the body level. So basically, you get that really awesome, comfy feeling. So when you install it under the floor system, it's completely silent, it's quiet, you don't hear it. It's great because it doesn't blow around your allergens and dust particles all over your home. So for anybody who suffers with bad allergies, in-floor heating is a great option for you. Most popular applications are going to be your bathrooms, your kitchens, and your basements. And as Scott mentioned, we have hydronic and there's also electric, which is what WarmlyYours offers.
Well, what's great about this drawing is in this drawing, you can see on the left side, imagine if this were a basement, you'd have a hot air vent here in the top, as opposed to most of the time in a basement, you'll have the air vents in the ceiling above you instead of down in the concrete slab. Sometimes you do, but most of the times it's up here. So if you have a vent up here at the top, that air comes down a little bit and then it goes right back up to the top where it gets hot, and then as it cools down, it comes down and goes into the cold air return. If you're sitting too close to the air vent, you're going to get really hot because the hot air is going to be blowing on you. If you get close to the cold air return, you're going to be feeling a very cool breeze as that warm air comes down the wall and goes down into that. With this product on the right, with the radiant heating, it's heating you in the room. It's heating the objects in the room, and as the objects give off heat, then that's where you get the heat in the air that you can feel. So if you take a look at this, the room on the right side is much more comfortable to sit in than the room on the left is.
Yeah, and you might notice too, like your actual air temperature maybe is not going to really increase, but your comfort level, it will really feel more cozy with the electric radiant heating.
Exactly. So let's talk about some of the differences between electric versus hydronic systems. Hydronic has been around forever. And then after Mary goes through these things, I'll talk about, it's not necessarily on a slide, but I'm going to talk about the major difference of hydronic versus electric. So Mary, talk to us about what type of heat source, what the perfect use is, the cost, all that stuff.
Okay, so with radiant heating from WarmlyYours, you're going to be using an electric mat or an electric cable, versus if you were doing it through a hydronic system, that's going to require heated tubing or piping with a hot water system running through the floor that way. So they are very different types of systems. The ideal use, which really makes electric a very good choice. It's great for small renovations, medium-sized projects. Um, you don't need a lot of, room in your breaker panel to do a electric system. It's applicable for new builds as well as large areas when you're doing hydronic. So there is a little bit of a difference on which one maybe suits your needs best. Um, but there is advantages to both systems. Cost upfront, lower cost for electric is definitely going to be your number one factor. Is makes it very attractive. To upfront cost is lower, whereas you're doing a hydronic system, you're talking about a lot more cost of expense in the overall operating cost, long-term costs, and that brings us right into the maintenance of it all. So with electric, you're not going to have hardly any maintenance whatsoever. But if you have a hydronic system, now we're talking boilers and valves and plumbing and HVAC and the whole shebang. So a lot more space in your home it'll take up as well. Um, Repairs, that's a big one, right, Scott?
Mhm.
Repairs. For electric, it's pretty easy. We have great troubleshooting tools that can ever help you if you ever need to. You don't require to remove the entire floor. You're just going to take, a pinpointed spot and easily get at it to repair it. If you have a hydronic system with a water system, you may have a very big leak or problem that could, progress into other rooms even that don't have anything to do with where the heating is located. So that could be kind of a nightmare. And materials, again, with electric, much more easy, just requires some cement, some basic, tools to set the floor. Nothing big, just some cement. And as well as if you're doing a hydronic, you're going to be talking like a big mass of cement. You're going to be talking like a big concrete pour.
Yeah, you're going from a half inch of self-leveling up to 4 inches of concrete. And the reason why that's important, not only here, because 4 inches of concrete is going to cost a lot more than a half inch of self-leveling cement, but also if you have to do a repair, it's much easier to go through pulling the LVT up,
Mm,
which you just pull it apart, lift it up, and go into a half an inch of self-leveling, as opposed to putting whatever the flooring is, then getting into that 4 inch pour and getting a
yeah.
jackhammer and getting into that concrete. So it's much easier to do the repairs and that sort of thing. One of the big things when it comes is differences of electrical and hydronic systems is hydronic. One of the things with hydronic is when it kicks in, the temperature goes up, and then as it goes and continues to go on, it's not quite as hot. So it's going up and down. The temperature's ramping up and down. That's calling overshooting and undershooting. And what it does is when it's laid out in the room, often when you have these tubes entering the room, they all enter in the same place and they all exit the same place.
Mm,
Well, the spot where the water comes in is always going to be much hotter than the spot where the water exits the room. So you're going to get more even heat. The temperature on an electric heating cable at the very beginning is the exact same temperature as it is at the very end. Hot water, it's very hot at the beginning and cool at the end. So that's going to be, that's why if you've ever seen an installation plan for a hydronic system, they're much more elaborate because they've got these tubes that are going inside and out of others so they can try to mitigate the hot and cold. So this system, you just roll it out or you just run the cable back and forth and you're good to go. Much easier to do that. And the reason why I brought the overshooting and undershooting of the temperature, if the temperature, like the aim is like 84, you may get water temperatures at the beginning that are 87, then it goes down to 80 as that pump and the boiler kicks in. If you've ever been in front of your register with a hot air system, with a forced air system, when that air blows on you, it's really warm, and then when it goes away, it kind of cools off, and then it blows on you and it gets really warm again. It's the same thing with hot water. That boiler kicks in or turns off, kicks in, turns off, and that affects the overshooting and the undershooting. The thing with our product, with electric, is you can keep it exactly the right temperature all the time because the thermostat controls that with a sensor in the floor. And we're going to be getting into that in a little bit. But why are LVT, luxury vinyl tile, and LVP, luxury vinyl plank, why are they booming?
Mostly, I think they are booming because of their waterproof durability. They really fit families with pets and children. It's just really become a easier installation. The flooring choice itself is probably more affordable luxury. You're going to get that beautiful looking wood floor without the expense of a hardwood nail down floor. Luxury vinyl flooring is really making up about 40 or more percent of the resilient flooring market in 2023, and we're still seeing that growth expected to keep on growing in 2025. Those flooring choice products really have evolved a lot over the years from something that looked really junky to something that looks really pretty now. So, commonly used LVP floorings are going to be in your kitchens, your basements, bathrooms, and we're really kind of seeing them throughout the whole house nowadays.
Yeah, the main thing, also one of the points that we need to get across in this presentation is if you've ever shopped for our products online on our website at WarmlyYours.com, they will go floating floor installation or tile. The thing is, these are a floating floor installation would be for laminate. Okay, when you see most of the nomenclature on our website talking about floating, that's usually a laminate floor that uses our Environ product. And we're going to be talking a little bit about that, but it's always important for us to say that this is not installed as the same way as laminate. Laminate and this product are installed differently. Even though this may install as a floating manner, it's still not the same as laminate. And we're going to be talking about that in a little bit. So let's talk about the heating compatibility.
So, heating compatibility with the maximum, I'm sorry, with radiant heating compatibility, yes, they are compatible for LVP floors with proper planning. You always want to check the maximum temperature and confirm that with the flooring manufacturer themselves. Most are going to be around that 82 to 85 Fahrenheit degree range, never more than 85 though. And radiant floor heating is also going to be compatible for a floating installation or what we're going to call a glue down installation. Again, you want to confirm with the flooring manufacturer's warranties and installation guidelines. The insulation value of the flooring itself, right, Scott?
Mhm.
This is important. So we want the heat to obviously come up and rise and keep you warm in your room. So we don't want your flooring itself to have a high R value on the flooring. So that is something to consider when you're talking about.
One thing you're going to find with LVT is LVT, the square, the old fashioned, that's what I picture them as, is LVT, the 12-inch square tiles, vinyl tiles. Those don't have a backing on them. They're usually adhesive and you stick them down with the adhesive. You peel the stuff off and stick it down. There's no pad in between. The difference between that and LVP is that the planks usually have an underlayment pad. So when you're looking at tile, you probably never going to find one of those peel and stick tiles that has an R value of over 1. However, when it comes to the planks can be in variable thicknesses, and you can see very thin or very thick. The idea here is to have the least thermal mass above the heater as you can. So that's where when someone says, I'm interested in getting an LVT or an LVP, a plank, one of the first things we ask them is, what's the R value? Because if it's a real thick plank with a real thick underlayment, there's a chance that the R value could be 1.5 or whatever. We don't want that. You want something that lets the heat through. The last thing you want to do is put a heated subfloor in and then put something on top of it that doesn't let the heat through. And that's where the R value comes in. One other thing that's not on this is when you're thinking about this, you're going to be asking them, what's the MAC temperature, all that other stuff. Another thing you want to ask them is can I do a setback temperature on this product? Which means at night, can I turn it down to 65 and then when we're up and awake, turn it up to 84. Then when we leave for the day, turn it back down to 65. Then at night, heat it back up again. A lot of LVT, LVP manufacturers won't let you do that. So that's very important to know because we call that a setback temperature from a higher temperature to a lower temperature. Because some will, if you look in their installation manuals, some will say a maximum deviated temperature of 1 to 2 degrees per day.
Oh.
Which means if you have an 85 degree limit in Fahrenheit, that means the only thing you can do is you can turn it down to 83.
Oh.
So you need to watch out for that. So if that's the case, you don't want a programmable thermostat because you can't program in different times of different temperatures. You always have to keep it the same. So if you want it at 85, buy a manual thermostat, and we'll show you the thermostats here in a little while. That's the one you're going to want because you can't do setbacks. So always check, can I do a setback and what's the max temperature that I can do?
Good information.
So let's talk about the different systems. I kind of touched on Environ before.
Hmm.
Environ is the fastest and easiest installation of any floor heating product that we sell because you simply just roll it out on the floor and you put laminate on top of it. And it's very, very simple. You don't have any cement, you don't have any thin set, you don't have any self-leveling because Environ never attaches to anything. Nothing ever attaches to it, and it never touches the cement. So that's very important to keep in mind. That's why we brought up the difference between laminate, which uses Environ, and LVT, LVP, which doesn't use Environ.
Where else in the USA can we use Environ, Scott?
Uh,
Under carpet?
Under carpet, yes.
Hmm.
Yep. But very good point. We're just what I was trying to do is floating is never always the same. It's just
Right.
yeah. So we need to get that across. But that's a very good point. Yeah, you can use Environ with carpet in the USA. So tell us about these different products and how they work with the LVT.
Okay, so my favorite choice for LVT, LVP products, anything you're going to self-level, I like to use the Temp Zone Flex Matte style system. What's beneficial about this is it's super low profile and it is already the wires attached to the netting, so it unrolls very easily. You can cut and turn the mesh netting to using our pattern on our smart plan that we provide you. So you can maneuver and fit to shape the heat mat to your space in your room. Um, the wires are only 3/8 of an inch, so it's very easy to put your cement right over the top of that and embed it up to a 1/2 inch thick. Um, that's my first choice. Our other choices that we'd like to offer for a little bit easier price point, right, would be our Temp Zone cable with grip strips or our new Temp Zone ruler cable with grip strips. The difference between those really is the ruler cable is set for our trade professionals who are in the industry, and the which is just a little bit differentiator based on the style of the cable itself. But both are very good to use for under vinyl product. And all three of those you're going to pour about a 1/2 inch of self-leveling cement over the top.
And all of these things will want to float to the top of your self-leveling. So
Mm,
whenever you're installing these, with the mat, always install it as much as you can, cable side down, wire side down, and the mesh on top. Because what you're going to be doing is you're going to be using hot glue to hold that mesh to the subfloor. So when you pour this self-leveling, it just doesn't float up into the top. So very, very important with that. If you're using cable strips and the cable, if you're doing long runs like across the room, 10 foot, 10 foot, 10 foot, 10 foot, you're going to want to take some masking tape every 2 to 3 feet, put the masking tape down along the floor to keep the cables from floating because they will float
mm,
and they will come to the top. And then at that point, I can't tell you the number of times we've had this call. What do I do now? It's all floated to the top. You're going to have to put another 3 or 4 millimeters or whatever it is
mm.
on top of that to cover that up. So you have to keep this stuff down and attached to the subfloor.
All right.
So what are some installation planning essentials that we need to know from a sales rep point of view needs to know to be able to quote you the correct thing? And how are you going to interact with them with these different things?
So one of the first questions I like to ask is, what is your subfloor? Are you starting from the first floor of your home on a wood subfloor or second floor of your home? Or is this going to be on a concrete slab like in your basement or your mudroom, or you're turning an enclosed porch or something where it's a existing concrete slab and we're going to go over it? One thing we want to know about that is if you are going to need a primer when you're doing over the subfloor. That's going to be important. We're going to want to know your thermostat placement. So we start the heat mat or cable closest to your power requirement placement, and your smart plan layout and electrical planning. This is really, really handy. We highly recommend it. Even if you have just a basic rectangular room, it still gives us a guide and gives you a guide to give to your electrician to show the power requirements, breaker sizes, junction boxes, gang boxes, everything you might need is going to be on those smart plans. Um, we also include the floor sensor placement on that plan, so that's important to know for your temperature control. And also, we want to know that the floor sensors that actually comes now complimentary included with your heat mat or cable. So you get one sensor in your box with your thermostat, and you get a backup sensor included with your heat mat or cable.
So you install them both, run them up to the thermostat, but only attach one and leave the other sensor balled up in the back of the box. In case that other one ever goes bad, you can take it off and put the other one in, and you are golden. So very, very important to get us the dimensions. Now we're going to be looking at a couple different plans, and please note coming up that we never heat 100% of the area. You're going to give us a drawing, and then we're going to give you a size of product that's already pre-sized. That's how we that's how we're able to ship the day you order. These are not custom sizes, but they're custom designs using various sizes and lengths to make it fit into your room. So keep in mind, give us the dimension of the room, not the area you're looking to heat. Give us the dimension of the room, and then you can mark if it's a separate area, but we're never going to heat all of it. We're not going to heat under beds a lot of times, or under a solid bottom box. You can heat under a bed. In fact, in this example, we do, but we had to know that in advance and how we're going to attack that. So also, you never want to put it under anything that's permanently attached, like a wardrobe. If a wardrobe is going to be sitting on the floor for the whole length of the room, you don't want to heat under that. Okay, so you stay away from stuff like that. And in bathrooms, you stay out from
Mhm.
under vanities, you stay out from under those types of areas. So get us the drawing, and then we can run with that. Now, talk to us about the differences between a slab, why it's so important for us to know what is this going on, slab or wood.
Yeah, so when you're doing that over concrete application, you're on an existing concrete slab on grade foundation or something. Um, that is important because what that slab is going to do is it's going to suck down some of your heating. So in order to prevent heat loss and get you a more energy efficient floor, a better performing floor, be able to turn it up to a little bit warmer temperature that you'd like, you're going to need to use what we call a thermal sheet if you're on the top of a slab. Thermal sheet is just a very thin sheet of material, comes in 2 foot by 3 foot piece pieces, and you're going to apply those with a modified thin set. Stagger them just like you would set some tile. Roll them out. Once they're nice and pressed down and adhered, you're going to apply your primer for your soft leveling. Put down your matter cable, and once that's nicely tacked down with lots of dabs of hot glue and some masking tape maybe also needed, then you can pour your leveler. If you're going on a wood subfloor, it's what you're going to need to do is make sure that you have the perimeters dammed up and any airflow vents boxed out so that that leveling cement doesn't run into your vents or anything like that. So you're going to make sure that the floor is all ready to accept that slurry of cement, and you just pour that once again pour that right over your matter cable.
So wood doesn't suck the heat down like concrete does. So that's why we're not installing the thermal sheet. That's why that 6 millimeter or 1/4 inch thick sheet of thermal sheet isn't required with wood, because it doesn't pull the heat down. One important thing when it comes to wood floors, also you want to make sure that there are no holes in the floor, because you want to make sure not only do you have to put a dam around air vents to keep that stuff from going down, you also want to put caulk around the edges of the room to keep it from going down in the walls, and also any holes in the middle of the floor that might have been drilled for something that you didn't end up using. You need to just put tape over that, something long enough to hold and keep that self-leveling from going down to the floor below. That could be very, very messy. And you can see right here
Mm-hmm.
what you're up against there. And if you look real carefully here on this picture back here, you can see that there's like a white line here. And this is in the closet. So you can't heat closets, but we're running the self-leveling over into the closet. So we have the same floor height all the way across the room. This is a run of caulk in here. So you're not getting that slurry going down into the walls. So you may notice that it's that white line that goes around there. That's the caulk sealing up that gap there. So notice on this drawing right here, you can see that the wires are facing down, the wires side down. This has been taped, not taped, but been glued in place every 6 to 8 inches, just little dabs of glue to hold it down, because you can see there as we're pouring over it, it's not coming up. It's
Right.
a nice flat sheen there where it's not raising to the top. If we didn't do that, you would see that cable physically just start levitating
Right.
up to the top of the pour. What are some other things you want to look for here, Mary?
Oh, acclimation period for your LVT or LVP product. That's always important, especially in the extreme summer or winter months. If you get a delivery and they leave it out in your garage for a week and then you bring it in the house, you want to let that flooring just kind of come up to room temperature before you begin. Always test the system before covering it. That is huge, guys. We definitely need to have you have an ohm meter to be able to test the resistance on the heat matter cables. We do include a circuit check, but there is a ohms test that is a required test that needs to be done. So you want to test it before you cover it. Um, use SLC to fully encapsulate the system. SLCs are self-leveling cement abbreviation. You'll see us throw that one around a lot.
We love that one.
Use SLC to fully encapsulate. When using SLC, you're going to want to check the bag instructions and follow exactly what the bag says. You're going to also want to maybe have a moisture meter to check that moisture for the requirements that also stated on the bag of cement you use. And you're going to try to maintain that coverage super even. Cables can be spaced at 3 or 4 inches. So that's what you're going to want to make sure you're maintaining.
Yeah, so do even spacing, because if you decide, hey, you know what, I'm not going to put any wire here. Where there's no wire, there's no heat. The heat only travels about 1.5 inches laterally from the wire itself. That's why the cables are spaced 3 inches apart. You get 1.5 inch coverage from this one, 1.5 inch coverage from this one, and that's what gives you the nice smooth heat. If you decide that, well, hey, you know what, I'm not going to put any heat over there, it will be cold. It will physically be colder than the area that has heat. So please keep that in mind. Also, the non-heating lead, the splice between the non-heating lead and the heating wire needs to be encapsulated in thin set or self-leveling cement. Now, if you notice, we don't say thin set in this. Thin set is not acceptable. And I personally have visited a couple of floors where they tried to do a couple things. First of all, never try to mix thin set thinner because it's cheaper. Never try to do that because, first of all, you have to mix the thin set as it's shown on the instructions, and you have to mix the self-leveling as it shows on the instructions. You're never going to go, you know what, on this job, I think it'll make it a little bit thinner, or on this job, I'll make it a little bit thicker. There's no decision to be made. You're mixing it in the proportion that the bag tells you to do it. So there's no custom mixing when it comes to these products if you want to get good results. And there's no way to get to get thin set flat, completely flat with a trowel. So the floor I went out to, they tried to get it as flat as they could. However, the LVT was sitting on, and you see it's an irregular surface. So where it actually does hit that, it feels solid. It's a nice solid step. But where that thin set curls down now is a hollow spot, and it hollow, good, hollow, good, hollow, hollow. So the floor was
Awful.
it sounded terrible. Brand new floor. So they had to do it again. Don't use thin set when self-leveling is required.
There's a couple other things we should probably point out on that slide, Scott, is maybe the tools that are needed.
Yes, good call. With this, when you're doing a self-leveling install, you're not using normal self-leveling tools. You're not using a gauge rake to get your thicknesses correct. Your thickness is the right height, because gauge rakes have little pins that stick down, and as soon as you do this and pull across it, you're pulling the whole system up.
Oh, that would be terrible.
And also, we had a job, I think it was last winter, where someone was wearing their self-leveling shoes, which have spikes on them, the self-leveling spike shoes, which are perfect when you're walking on top of a concrete floor being covered with self-leveling, because they don't leave footprints.
Right.
So that's great. But this person wore his shoes anyway and damaged the wire in hundreds of places because he was walking around with his gauge rake trying to get the self-leveling the right thickness. And it just, as you can guess, it turned into a comedy of errors. So you're not using normal tools here. You're using your regular tennis shoes, sneakers, or trainers, as they say in the UK. And you're using a squeegee. You're not using a gauge rake. So thank you, Mary, for bringing that up.
Okay, so this brings us to our thermostat options. We have a wonderful new thermostat called the Enjoy Wi-Fi thermostat. This is a thermostat you're going to control with a app, voice schedule. We also offer the Inspire Touch. This is a nice, sleek, and easy to use model. You can walk up to it and touch it and program it right on the face of the unit. We have the Entrust 2.0 with a manual control and a very simple interface. And this was one that Scott mentioned earlier, was kind of nice if you don't have that setback temperature, right? Yeah, and the Entrust is really great for those folks that are just going to set it and forget it. I mean, many people will just put on their radiant heat in the cold weather months and let it ride. And that's a really good option for them. Always pair with the floor sensor. So these thermostats come with a floor sensor, as mentioned. We mentioned earlier as well. Your heating element will come with one. Put both your sensors into the floor, but only connect one at a time.
Yeah, and the Entrust 2.0 looks very similar to this. It's got a white face, so it kind of like blends right into the wall. If you have white walls, it's very unobtrusive.
Mhm.
And that is going to be your control of choice if you are not allowed to use setback temperatures. So that's what you're going to use. You're going to set it to 85 and leave it there forever. But at the beginning of the season, the heating season, and at the end of the heating season, if you're starting with a 70-degree floor and you want it to get 85, you just don't go, okay, it's Monday, I'm going to set this to 85, and tomorrow it'll be 85, it'll be 15 degrees warmer. Can't do that. You've got to do, depending on what the manufacturer of the flooring says, you can do 2 degrees today. So you're going from 70 to 72. Then tomorrow you're going to go from 72 to 74. Then the day after that, you're going to be going 74 to 76 and on the way up to get to 85 or 84, wherever you want it. And it's the same way at the end of the year. At the end of the year, you're going from 85 to 83 to 81.
Which made me think just now, because I'm like,
Uh-oh, I know we're in trouble
yeah.
now.
I was just thinking, I'm like, well, if you're new to floor heating and your client would be new to floor heating, maybe
Yeah.
they've never had it before, I would think that's really a great way to start them out, just so that they know, like, how hot do I really want it? Because to me, 75 sounds hot enough, but maybe it really doesn't feel hot enough. So if you just do that 2 degree a day and start them off that way, I think that's going to be the safest way to go anyway.
Yeah, to where it feels comfortable to
Yeah.
them. So that's one thing you want to keep an eye on is at the beginning, we call it commissioning, and then turning it off at the end of the year. It's just not going from 85 to 70 or whatever that is. And just for an aside, that's the same way you do hardwood
Oh yeah.
or engineered wood too, that have setback temperature requirements. Like a floor I put in locally that was a nail-in hardwood floor, we can do those at the beginning of the season, up 2 degrees every day, and at the end, it's the same type of thing. So let's talk about how we can help the customer when they call us.
Um, the smart plan, really, everybody should have a smart plan. It's free. It doesn't take us more than just 1 day turnaround time to get that back to you. The beauty of the smart plan, and you can see on here, there's some great notations. All of our plans have a plan number. We have our toll-free number listed there, project name, room name. We describe the flooring type on the plan. We tell you which heating product we're using. We tell you the voltage, the wattage, the amperage, all the important information that you're going to need for the setup of the units themselves. Visually, what's nice here is you can see the dimensions of your room. You can see the start and end of the heating element. All of those very important icons are mentioned for you. So when you get this plan back from us, you're going to want to take a look at it and verify that this is the correct size and shape of your room. You can see that the dimensions that we have there in green are showing you like the little edges where we're coming off the edge of the mat to the wall. And the dimensions in red are going to be the outer perimeters of the room itself. So you kind of know where to set that mat and position it in your room so you're not too tight up to the walls. And then it's just a cut and turn pattern, pretty simple to follow.
Yeah, and people ask, well, how many watts is it going to take? We'll tell you. As soon as we get your drawing done, we'll tell you the watts, we'll tell you the amps, and we'll also tell you what size breaker to go out and buy. So it
Correct.
takes all the mystery out of it. So the main thing is that the T is where your thermostat is, and that's where we're always going to start the design. If you tell us that the T is going to be over in the upper left-hand corner, we're going to redesign this room so the lead can reach that way. The lead is only 12 or 15 feet, so I can't put a thermostat on the other side of the room and get the lead all the way back to it.
Oh yeah.
So we're definitely going to know the beginning of the mat is a triangle, the end of the mat is a square, and the T should be somewhere in the near vicinity of the triangle. So that's what you're going to be looking at on your plan. Also notice we're not heating every square inch of this space. We're pulling away from the walls. Part of the reason we heat away from the walls is no one ever stands there. No one ever stands, this is a lineup, stand right up against the wall. You don't do that at home. You do that at the police station, but you don't do that at home. So there's no need to heat the floor there.
Right.
So that's why we pull it to where you're going to be walking. It's very important to get the heat where you're walking and then kind of, oh, it's okay if we don't walk on it. It doesn't need to be heated. So that's a main thing to do too. So let's take a project example that we did with the temp zone mat, And this is the install I think I did on the day that my filling fell out. So I always remember this one.
Yes, this is the temp zone mat system. We're quoting for a 240-volt system here. We're going to tell you how much area that's going to cover. Again, this is kind of the whole project overview, shows you the, again, the wattage, the amperage, the required breakers. Scott, why does it say a non-GFI circuit there?
Because the GFCI protection is included in the thermostat. And
Right.
you never want two GFCI devices on the same circuit because that causes nuisance tripping. When one of them turns off, the other one sees that as leakage. Like, ooh, there's a problem, so I'm going to turn everything off.
Yeah.
The last thing you want to do is spend all this time and spend the money and the effort to get this system put in and then have a nuisance trip every 2 or 3 hours where the system literally shuts off.
Right.
Okay. It doesn't keep eating. It doesn't say, hey, I think there's a problem. It goes, I think there's a problem. That's it. And most of them we see are because electricians know that you have to have GFCI protection with floor heat, but some of them don't realize that the GFCI protection's in the thermostat. And now they've created a trouble with these two GFCIs fighting each other. So that's why it needs to be a non-GFCI circuit.
And for those that aren't familiar with the GFCI, that stands for ground fault interrupter.
Mm-hmm. Yep. Yeah. Yeah. So congratulations. Mary will be getting a high five off camera, but keep in mind that it's very, very important for some people. And I run into this case quite often where they only want to run one circuit up to a small bathroom on one side and another small bathroom on the other side. So they only want to run one circuit up, but now they're feeding this thermostat and feeding this thermostat.
Oh.
And now these two thermostats are on one circuit and this one kicks off, the other one sees that as a problem and shuts down.
Ooh.
So you cannot have two GFCIs on the same circuit. So one feed with a thermostat and another thermostat, or it's the same thing with, and Mary can talk about this, large installations where we do a thermostat and a power module because it's over 15 amps.
Mhm.
Each control can handle 15 amps. That's it. Now, if you have two small cables attached to a thermostat, that's cool as long as they're less than 15 amps. But you can't put a 12 amp system and an 8 amp system on one thermostat because you can't do that. So you put one on a thermostat, one on a power module. These two items have to be on separate circuits. Otherwise, you run into the two
Same
controls on the same circuit issue again, which is called nuisance tripping.
Yeah.
So when we're troubleshooting these systems, we always ask them brand new installation. Please go down and check the breaker powering the thermostat. Is it a GFCI or not? And they go, oh yeah, the electrician said to put one in. Well, he was right, but the thermostat has it. So take that out and put a regular breaker in. One other thing on this page I want to take note is that notice the dimensions. Total area is 161 square feet. We're not heating. Remember, we don't heat 100% of the area. That's why the heated area says 129. It's a portion of that larger 161. So if we take a look at this, this is 240. We chose 240 for a reason, not because 240 is more efficient, not because it heats up faster, because of what reason?
Because 240-volt will draw half the amperage of 120-volt. If we were doing the same project in 120-volt, we'd be over 16 amps, which would exceed the amp load available on a single thermostat. So if you wanted to do the same size room in 120-volt, you're still going to need two circuits. That goes back to needing a power module, which is not ideal. You'd be much better to just bump that up to a 240 double pole breaker, non-GFI, and go with the 240-volt system for that size heated area. I always kind of thought when I first started here, the easy way to remember was 120-volt kind of equals 120 square foot of coverage. So anything, if you once you hit that 120 or more square foot, you're definitely going to be going up to a 240 breaker.
Right. Because you can see this amperage here at 240 is 8.1. This would be 16.2 in 120. So what we try to do is I feel comfortable in saying that most of our jobs are less than 120 square feet.
Yeah.
Our sweet spot is a master bathroom that's 60 square feet, 50 to 60 square feet, something like that. There's no need to put 240 in there because 240 uses two spaces in your breaker box.
Correct.
You only want to use one space in that breaker box and save the other spaces for something else.
Yeah, nowadays we definitely need more power in our homes as it is. So don't take up two poles if you can get it all on one is really what's best recommended, I think.
Right. So don't let somebody push you into a 240. You're not going to get any
Yeah,
benefit on a small room, and you're going to be using an extra breaker in the breaker panel. So watch out for that.
right.
So let's talk about this particular plan. This particular plan is that self-leveling job that we've shown,
Mhm.
and the thermostat is over here on the left, and the start is right here. That's a triangle, and that's roll number one. There's only one roll here, but we always number them. And then that coincides with the number down here. So it'll tell you what system is used. So we know how many watts per square foot. We know what size breaker. We know what the floor is. We know what the subfloor is. All of these questions that we're asking you when we're setting the order up. So this is also telling you what I want to do is because it's less busy. I want to show you this right here. And then we're going to show how it relates to cable
Okay.
installs later. But here we can see this 1 foot, 1.5 inch mark here. That's the space from the wall to the edge of the heater. Okay. So we then go around the perimeter of the room and we see a 6 up here. That's the distance from the wall to the heating product here. Then we have 1 foot, 1.5 inches from this wall to here. So this is an unheated area. But remember, it's always most important to keep the heat in the space where you're going to be walking around. Always remember that you may get a cold step on the way out, or you may get a cold step on the way in. But that is better than putting this product right up against the doorway
Right.
and having somebody nail it, a transition in here and ruin your system. So we want the area in here, the contiguous area, to be warm. You may get a cold step here. You may get a cold step into the bathroom here.
Yeah, and we've got to remember too, we like Scott mentioned earlier, these are stock size heating mats. These are not custom made pieces of heat mat or cable. These are stock, so we're going to fit the best size for the room based on the dimensions provided.
And that's a very common question we get all the time. Once I order this, how long is it going to take you to send it to me? Well, we're going to send it to you the day you order it because we're taking that stock size and then you're going to cut it into these shapes when it gets there. You never ever cut the heating cable. You never shorten a mat. You never cut the mat. You never wire two mats together.
You never order the biggest one possible and try to just say, I'm going to use half in this room and half in that room because that's not going to work.
We've
We've had that.
we've lived through that multiple times. So you can't do that. You can't buy one big spool and then cut it and put it in different rooms because then you're in trouble because it overheats really, really fast. And why these distances are mentioned, it's very important when it comes to cable because you can really mess up your cable install if you don't pay attention to these numbers in green. And we're going to be talking about that. Once again, we don't heat closets. The National Electric Code in the United States does not allow the heating of closets, but in Canada they do, as long as you have a control in there to control the temperature. So if this were Canada and we were heating the closet, there'd have to be a thermostat in here.
Oh.
That's how that works. So let's talk about what's going from left, center to right.
Okay, so on the left, it looks like the installer there is on the floor taking an ohm reading with his digital
That's me, as a matter
ohm
of fact.
meter.
That's me. You can tell by the bad watch.
The digital ohm meter, he's taking the readings of the floor to make sure that the heat roll is fully intact before he even begins. He's checking to make sure he's got the right size material, the right size voltage, and he's ready to go before he even starts anything.
Yep, there's a red tag on that roll. For those with really good eyes, that red tag means 240. If this were a 120 system, that would be yellow. And the wires coming out the end would be yellow and black. This is 240. It's got a red label and it's got red and black wires sticking out of the cold lead. That meter right there costs $19.99 at any big box store. Don't go out and buy a $500 meter to do this job. You can do it with an inexpensive meter, and that's the best meter to use. Because we're not only are we just going to be testing the floor cable and mat or whatever we're testing, we're also going to need to be testing the sensor. Got to test the sensor before you put it in, both of them. And the problem with self-ranging meters is they'll hone in on this product that's down, because it's under 200 ohms. So this may be 70 or 80 ohms, and it'll see that. But your floor sensor is between 8,000 and 18,000, and your meter sometimes doesn't switch to that range. So you either have to hit range until you get a good reading, or it never shows up. That's why we don't like self-ranging meters. Digital non-ranging meters. So here we can also see in the middle that the self-leveling cement is about halfway installed.
Yeah, that's just showing you how you're going to be carefully walking across that, pouring that down, um, and just evenly coating that whole subfloor, that whole floor to embed that system about a half inch deep. Um, that's what's going on in that picture, and then your final picture is your finished room. Looks like.
Yep, we've got the same flooring all the way across in the closet, but there's no heat over here, but there's self-leveling over here. Also, you can see the white line going around the room, around the perimeter. That's that caulk line we talked
Mhm.
about before to keep the self-leveling from going down inside the walls. And remember, this product has been very well attached to the subfloor. Now, self-leveling, when you put the self-leveling is, you never change the way it's mixed. You always mix it exactly as it shows on the bag. And 9 times out of 10 on that bag, it'll tell you a couple things. It'll tell you what primer to use. Okay,
Mhm.
you have to use primer 99% of the time, and it'll tell you what kind is required. And it'll also tell you how long it takes to cure because you don't want to turn the heating system on before the cure is complete. Because if you turn the heat on, it's like, oh, you know what? And I've heard this a dozen times too. I'm going to turn the heat on so it cures faster. Oh,
Mhm.
oh no, you're not. You're going to turn the heat on and you're going to cause the curing to stop.
Mhm.
And then it's going to become very brittle and start cracking. So
Mhm.
you never ever heat thin set that isn't cured or self-leveling that isn't cured.
Never energize the system without putting it under cement too. That's a pretty good important one.
I learned that the day I started here. I go, oh, what happens when I attach the power and it's still all rolled up? In
Yes.
about 3 seconds, it
Yep.
got very, very hot because all the wires are right on top of each other. That's why the wires can never go in the wall. I can't tell you the number of times I've seen people where they take cable and they tie it together and they stick it in the wall
Mhm.
because they had too much. You can't do that. You
Yeah.
can't do that.
The guy with the without the ohm meter who says, "Oh, I just connected it to see if the cable was working,"
Boom.
and
Right.
then yeah, then you just blew the cable because it overheated.
And overheated. So yeah, always watch out for that. So let's talk about the same project using cable. So what's going on here?
Okay, so here we are with the cable style system. We are still going with a 240 volt, once again, non-GFI. And heated coverage area, we have the same size room, but you notice the heated coverage area changed slightly. It's just a little bit based on this way we space it out for the room. Um, but yeah, basically it's a little bit less expensive option with the cable because you're doing a little bit more manual labor to install it by stringing it back and forth.
Right, and the heated area changes a little bit because of that, because the cable's more flexible, you can get it into different areas. But we can see we used a little bit more amperage too because we
Mhm.
had more area covered. So let's take a look at this page. And now this is the cable setup. And you can see the cable fixing strips are on the perimeter of the room
Mhm.
on one side and then on the other side. Now let's take a look for those green markings and see what they say. 5 inches from here to here, 5 3/4 inches from here to here. Same over here, 5 3/4. Now, for an example, let's say that I don't, you know what, I'm going to move this cable fixing strip over here and I'm going to put it a foot away from the wall. I'm going to take this one and put it a foot away from the wall. That's going to leave me with too much cable at the end. I'm going to have this red dot. What is this red dot, Mary?
That red dot indicates that you're halfway through the cable. So when you're following our plan, looking at the plan, you're going to see the red dot. When you're unspooling the cable, when you come to the halfway point, it will be marked with a piece of white tape. And that tape spot should line up pretty darn close to where that red dot is. And if you're not near that space in the room, you should check your work, see what changed, if you're following the plan correctly or not, or and then obviously check your material, check it, and
Mm.
then call us if you have further questions. But that dot needs to correspond with the halfway point of your cable.
Now, these cable fixing strips have loops every 1 inch, so you can do your spacing correctly.
Mm.
If you're getting to the space here where you're using up too much, you're probably at 2 inch spacing, which is a big problem because you can't do 2 inch spacing. If your red dot has moved all the way over here, it means you might have been doing 4 studs instead of 3. So
Mhm.
you're doing 4 inch spacing instead of 3. So you're going to end up with way too much cable.
So it's important to pay attention on the plan and how we space it for you, because there are some times where it will be requested at 3, and there's other times where it would be requested at 4-inch spacing. So again, it's always based on what the plan is, based on what your cable length is.
And also, if we moved, conversely, if we take our cable fixing strips and just put them straight against the wall, we're going to run out of cable. The cable's going to stop up here because we're not taking it, we're using too much
Yeah.
per foot. So those are the things that you want to keep an eye on. Always keep track of these numbers. Where is it from the wall that you're going to be?
And we kind of show you that dotted line there. That would be the outline for the bed and the nightstands there. But in this room, on the next slide maybe, we do know that this bed is on legs. It is not a box style bed. It's not a water bed from the 90s or 80s or anything like that. It's a bed on legs. And the other area is that is an open like dresser that's also on legs.
Yeah, you have to let the heat out. So that's where you're going to be. Any bed that has drawers on the bottom, you're not going to want to heat under. Anything with a box bottom, a flat bottom, that's going to be bad. So here we can talk about, quick look at our progress. We're showing here, I like this picture. It's kind of a repeat, but I like the way that we're showing the wiring, the self-leveling going over the cable as opposed as the mat. But here you can see the red product right here. This red line and this black line means it's a 240 system. That's how you know what that is. And there's the ground. Now, another big question we get all the time is, where do I attach this ground? There's no ground terminal on the thermostat. Well, this ground gets tied directly to the house ground that's in the box that the thermostat's going to be in. So that's where that gets attached to. It doesn't attach to the thermostat. It attaches to the house ground in the box. So now is a perfect time to ask any questions. We did have a question from Dondi, and it miraculously just disappeared here, but I think I remember what it was. It was a question about heat transfer. Which is better, to use tile or to use LVT or LVP? And my question, first of all, is going to ask Mary, does tile usually have a temperature limit, and does LVT normally have a temperature limit?
Tile does not normally have a temperature limit, but LVT, LVP, SPC, any of those type of composite floorings typically will have a temperature limit.
Right. So for you NASCAR fans out there, I'm going to go NASCAR for you and talk about a throttle plate and a restrictor and all that other stuff. You have the same car, two cars, one that doesn't have the restrictor plate on it, one that has the restrictor plate on it. This car goes 190 miles an hour. This one goes 150. Which one do you want to heat your room with? Which one do you want to win with?
The one without the restrictor.
The one without the restrictor. So the tile, in this case, the perfect analogy to this is the tile is the product without a restrictor, and LVT, LVP, engineered wood, carpet, any of those type products are all throttled down. You can't go beyond a certain temperature limit. So if you had to heat an area like a 3-season room, which normally has a lot of heat loss, like skylights, like multiple windows, where that heat's going to escape, do you want to put an LVT product in that room, or do you want to put a tile product in that room?
My choice would be a tile, the actual tile product in that room.
Because it's going to heat faster usually. It's going to transfer more heat into the space.
Correct.
Right? And so that's very, very good question, Dondi. Thank you for asking that, because we do run into people's like, I want to do a 3-season room and I'm thinking about putting an LVT out there. And we have to say, well, you might want to rethink that because the reasons we just talked about before.
One beautiful thing though is if your client did decide to do that and self-leveled in the whole floor, put on their LVT or LVP product, if they decided in a year or so that it wasn't as hot as they thought it would be, they could pull that back off if they just floated it over the already leveled out floor, and then they could then install a tile over that self-leveled floor probably, right?
Right, exactly. So that is one of the benefits. We do have a question here, so I'm going to get to that in a second. But we have the benefit of what we're talking about here is we're talking about creating a heated subfloor that we're putting the LVT, LVP, or whatever on top of. if we get tired of that LVT, or if it wears out, or if it gets damaged, somebody drops a hammer on or whatever, you can actually just pull it up and then back butter tile and put the tile
Right.
down with thinset, and now you have a tiled floor. So you can do that because you've generated a heated subfloor. So what do we have here from Brent? Answer live. So in an application where the floor system has a bit of flex and you are concerned with the self-leveler cracking, can you use your cable in a product like brand X, or we sell Prodeso, which was the original product? Um, we are not worried about really with floor flex with LVT because there are no grout lines to break. There are no tiles to pop. So even if you do get a hairline crack in the self-leveling, underneath your LVT, no one's ever going to know. You're never going to see it. So we're really, with this particular product, we are not concerned about the floor's got to be in decent shape.
Yeah.
It's got to pass deflection tests, but this is not a floor that you want to spend money on an additional membrane because you don't have to worry about cracks in the grout. You don't have to worry about tiles popping. It's just simply a heated bed. So that's a great question, Brent. I've gotten that question before. Mary, you have something to add?
Yeah, I was thinking about like how would you prime over it, like if you had that style system. I mean, we need primer for self-leveling. So if you were trying to put that with a membrane style system, I don't know that would it work as well with that?
In fact, we don't even
We don't even test
recommend,
it that way.
there's only one or two companies that make self-leveling that gets warranted over the top of a membrane like that. And it's a very specific application. Prodeso is designed to not use or need
Primer.
self-leveling, self-leveling. So it doesn't matter because it's impervious to water. So it's not recommended. We can't say to recommend it, but however, if you, let's say that you have a specific tile that has to have self-leveling, there may be small tiles or glass tile or something like that. You may have to use that. If you're going to use an underlayment, we recommend using the Prodeso and then the self-leveling that is warranted. And if you'd like information from us, there are a couple brands and model numbers of self-leveling who have their own warranty when installed over the top that they'll cover. So that's an application, very, very specific application, but 9 times out of 10, we don't suggest using a membrane under. That's a great question though, Brent. Thanks for asking. So I don't see any more questions. So if you have any more, continue because we have some maintenance here to do real quick. So on Tuesdays, we have training. We do Radiant Expert training. I do some of those. A couple other people do some of them. Tuesdays at 4, Wednesdays at 4 p.m., and Thursdays at 4 p.m. So watch out for those. Also, Mary, tell us about the program and how to get invited to that.
So if you are a trade professional and would like to become a WarmlyYours professional, please let us know. We would be happy to connect with you, set you up with your dedicated account manager, who will be your number one go-to person for all your radiant heating needs. Um, of course, you're going to get your free smart plans and exclusive pricing. That's always very attractive for trade professionals. So you can have a little incentive to promote the products. And just give us a call or contact us at pro@warmlyyours.com.
Fantastic. So let's talk about our next webinar. That's in July. It's always odd to be talking about stuff like this that deals with ice and snow and freezing and stuff when it's 99 degrees and 90% humidity. But really, that's the time we need to talk about it because that's the time you need to buy it and install it.
Correct.
Very, very important. So we're going to be talking about preventing ice damage with radiant heat. It's going to be a guide for pros on residential and commercial applications. And so pipes, roofs, gutters, that sort of thing. So tell us about the June promotion.
So along with the floor heating webinar we just did, we are offering an additional 10% off on our temp zone heating products. This is good for any of the temp zone flex rolls. I believe it is good for the temp zone easy mats, as well as the temp zone cable. That would be the red style cable.
So visit our website, warmlyyours.com. It's right there at the bottom of the page. So thank you for watching today. Thank you for your questions. We appreciate it. If you have any ideas for other topics that you'd like to see covered, please let us know. We'd much rather talk about something that you're curious about than for us to go, hey, you know what? Why don't we talk about this month? So please let us know. We appreciate you taking the time to watch today. We appreciate you taking the time to ask questions. It's very, very beneficial, not only for us to kind of go off the beaten track a little bit off script, but it's great. So thanks for everybody that took the time to send your questions in advance. So I'd like to thank you so much. We will see you next time. On behalf of
Mary.
I'm Scott, and thank you for watching. Be connected, be warm, and be radiant. Have a great day, everybody.
Bye-bye.